All right, guys, so one final example here to really just drive home these concepts and prepare you for your homework. I really should have made this example in the previous slide in this bolder kind of font as well. I think it looks better. All right, so we're going to do another example and just kind of get you prepped for the homework assignment and make sure that everything is clear. And so in this circuit, I'm going to go ahead and draw, let's say I have a 5-volt battery here. And then I've got a resistor here. And now I'm going to connect another voltage source here. And let's just say that this one is going plus to minus. And I'm going to call this a negative 2-volt voltage source. Okay. Never seen a negative source before, but it's nothing to be afraid of. It's pretty straightforward. Let's say that this is a 1 kilo ohm resistor. And we'll go ahead and call this VA, and we'll call this VB. You can call these nodes whatever you want, whatever makes you comfortable. A lot of times in the homework assignments, I'll just pre-label them for you based on whatever I was feeling at the time. But whatever you want to call them is fine. Typically, we just call them VA, VB, or V1 and V2. Sometimes V in and V out, depending on the circuit. But okay, in this one, we want to determine all the voltages labeled in the circuit. So we're going to determine voltages. And then we're going to also determine the current flowing in the circuit. All right. So I'll label my current in the circuit. Will just be, call that I. I guess we'll just call it I in this case. All right. So we're ready. So if we want to determine the voltages, there's only 2 of them. Obviously, similarly to the previous example, we have a ground net here and we have a ground net here. So we know right off the bat that this is 0 volts and this is 0 volts. All right. And so now all we're left with is the other 2 nets, which are VA and VB. All right. So similarly, I'm not going to take too much time on this. VA is pretty straightforward. We know that the rating of our battery is 5 volts. We know that this side is at 0. We know that the plus side has to be 5 volts higher than the minus side. So therefore, this voltage, VA, is 5 volts. So right off the bat, I can say that VA is 5 volts. Pretty straightforward. All right. Now in this case, we have a negative 2-volt battery. It works pretty much the same, actually exactly the same. But because there's a negative, you might be inclined to flip things twice or to undo what you've already done when you're trying to find VB. But it really is just as simple. We have 0 volt side. The negative side is at 0 volts because it's connected to ground. And my plus side would be whatever this voltage is higher than the 0, which since it's negative 2, this would be negative 2 volts higher, or really 2 volts lower, you could think of it as, because the minus sign would kind of flip the script on us. But really all it's telling me is that I take this 0 volts and I'm going to go up by the amount that is labeled here, which is negative 2 volts. So if I'm going up by negative 2 volts, it's the same thing as going down by 2 volts. And one way or another, I'm going to end up with negative 2 volts at VB. So therefore, my voltage VB is simply negative 2 volts. All right. So I've determined my voltages, and now I need to determine the current flowing in my circuit. Well, what I can really do is just kind of, let me take my laser pointer. I can kind of extract this part of the circuit, the VA, VB, and the resistor, and I can determine the current very easily using Ohm's law. All right. So actually what I'll do is I'll just draw that right here. I'm kind of taking, again, I'm going to just take this piece out and draw it right here. So I've got VA, which I know to be 5 volts, and I've got VB, which I know to be minus 2 volts. and then I know that my resistance is 1 kilo ohm, and I'm trying to determine the current that's flowing in my circuit, okay? So using Ohm's law, I can say that V is equal to I times R, and I recall that the V that we're talking about here is the voltage difference V across my resistor, which in this case is going to be equal to 5 volts minus the voltage on the other side, which is negative 2 volts, okay? And so that is equal to I times 1 kilo ohm. And so I can say that 7 volts, because it's 5 minus negative 2, which is 7, is equal to I times 1K. Or I can say that finally I is equal to 7 volts divided by 1 kilo ohm, which gives me 7 milliamps. All right. So we solved for the voltages, we solved for the currents, and that does it for this example problem. So hopefully everything here is pretty clear. I know the negative voltages can be confusing, but really it's just a matter of going from 0 to whatever the voltage rating is. You notice that in this case, I went from the voltage rating was 5, so the positive, if the negative side of the battery is at 0, then the plus side is just at 5. Same thing here. If the voltage rating is negative 2, the negative side of the battery is at 0, then the plus side is just at negative 2. It really is just that simple. Hope everybody has a good time solving the problems on the homework. Obviously, if there are any questions, I'll be happy to answer them. And with that, I'm going to sign off on this video.